गुड मॉर्निंग. आवाज येतोय? आवाज येतोय का? जरा इकडे बसायचं समोर. Good morning, all of you. So we have started the unit number 3. That is measurement of acceleration, velocity, and displacement. Okay. In last lecture, we have covered the position sensor and displacement sensors. Also, types of position sensors. LVDT is completed in previous chapter. Okay. Then capacitive sensing element, capacitive sensors and displacement sensors. Okay. So today we have started new part. Slide. Today we have started new point, that is gyroscope. Give the heading gyroscope. Gyroscope, gyroscope. Basically, this device is used for angular velocity. Draw this diagram only here. Draw this diagram only. See the construction of gyroscope. This rotor or balance the weight is attached with the help of three gimbals, 1, 2 and 3. तीन गॅम्बलच्या मध्ये रोटर और बॅलन्स वेट आहे. ठीक आहे. त्याच्यावरती ग्रॅव्हिटेशनल फोर्स ऍक्ट होतो आणि यानुसार हे this is the working. Weight is fixed and rotate three gimbals around its axis. That is balance, weight and spin axis is fixed, and these three gimbals 1, 2 and 3, these are rotate around this rotor or balanced weight. Okay, so first question is that why gyroscope is used? Write down only question, why gyroscope is used. Okay, so please tell me are you heard this word gyroscope, where it is used? Don't read this. Steering mechanism, basic steering mechanism, and again aerospace, then satellite, ship wheel mechanism, and also missiles. Compass, magnetic compass, needle shows as a direction as a north always. In that instrument gyroscope system is installed. Okay, see, gyroscope are used in compasses and automatic pilots on ships and aircraft in the steering mechanism. Also our Tom Lab gyroscope system is there. Of torpedoes and in the internal guidance system, installing space launch vehicle, ballistic missiles and orbiting satellite. Angular and orbital. These are the two different concepts, angular and orbital. Angular means one angle, like this horizontal, and this is 30 degrees, 60 degrees, 45 degrees, 90 degrees. This is angular. And orbital means about its axis, circular. Okay, configuration, basic configuration, atom, anion, cation, then nuclear. This concept is orbital concept. Okay, then see the principle. It consists of spinning mass that rotates around its axis. Balance mass, rotor or spinning mass is rotate about its axis if gyroscope is installed on gimbals. Gimbals means the thin ring that allow the mass to navigate freely in the three-directional space, X, Y, and Z axis means rotational axis. Three-directional. Pitch axis, Y axis, and roll axis means rotational axis. Here, see this direction, three directions. Okay. Its spinning axis will remain oriented in the same direction if even it is change the direction. After completing this theory, I show some video related to this gyroscope construction and working. Okay. The next question is, how do you find the angle of tilt? How do you find the angle of tilt with this help of gimbal? Three gimbals is there. How do you find out the tilt of angle? Rotor or balance mass axis is fixed and three gimbals are rotated about its axis. One is rotating x-axis, one is y-axis, and one is rotational axis. But this rotor and balance mass are fixed with the help of spin axis. Spin axis ला balance mass fix आहे त्याच्यासोबत 3 गॅम्बल फिरतात. x डायरेक्शन ला, एक y डायरेक्शन, एक रोटेशनल डायरेक्शन और z डायरेक्शन. ठीक है. On way to measure tilt angle with reference to the earth ground plane is used to axonometer. Typical application can be found in the industry and in game controller. In aircraft, the ball in turn coordinate or turn and bank indicator is sometimes referred to the inclinometer. So, भाषेत सांगतो, in gaming section, sometimes you push the forward button or running button. Okay, and then exact position you remove this your thumb for this button, but the object is moving some forward. आपण फॉरवर्ड बटन प्लेस केलेला आहे, आपला ऑब्जेक्ट आहे तो रन करतोय, पळतोय किंवा चालतोय. पण आपण ऑब्जेक्ट बटन वरून आपला बोट काढलं तर काही डिस्टन्स तो ऑब्जेक्ट आपला तसाच पुढे जातो. गेमिंग सेक्शन मध्ये एक्झॅक्ट आपण बटन काढतो थांबतो का? नाही, त्याच्या मोशन मध्ये असतो. त्या मोशन फॉर एक्झाम्पल त्याच्यापेक्षा बेसिक गाडीचा ब्रेक दाबल्यानंतर लगेच गाडी थांबते का? त्याची जी काही मोशन आहे त्या मोशननुसार ती थांबते. इवन दो युअर डिस्क ब्रेक, you apply disc brake, rotation of wheel is stopped, but motion of this vehicle push this vehicle to somewhat distance. स्पीड मुळे त्या गाडीला काय करते, पुढे खेचलं जातं. डिस्क ब्रेक यूज केला आपण टू व्हीलर फोर व्हीलर तर व्हीलचं रोटेशन आहे, मोशन आहे ते स्टॉप केले जाते. पण स्पीड असल्यामुळे त्या गाडीला काही डिस्टन्स गाडी पुढे जाते. त्या कन्सेप्ट नुसार आपण टिल्ट अँगल फाइंड आउट करत जातो. हे रोटेट आहेत, ऍक्सिसला रोटेट करतो. मग आपण एक्झॅक्ट पोझिशनला ते आपण हे करणार आहे का? आपण काय करणार, त्याचं स्पीड चेक करणार. हा एक्स ऍक्सिसचा जर रोटेशनल स्पीड चेक केलं आणि एका ठराविक पोझिशनला आपल्याला ते अँगल फाइंड आउट करायचा असेल तर आपण इथं असेल तेव्हा तो अँगल घेणार, कारण तो तिथं गेल्यानंतर पुढे जाणार आहे मोशन मध्ये, सर्क्युलर मोशन मध्ये. क्लियर? Okay, write down. A gyroscope is a device used for measuring or maintaining orientation and angular velocity. Next line. It is a spinning wheel or disc. It is a spinning wheel or disc in which the axis of rotation in bracket spin axis is free to assume any orientation by itself. Full stop. Then next, when rotating, the orientation of this axis is unaffected by tilting, or rotation of the mounting according to the conservation of angular momentum. According to the conservation of angular momentum. Then write down these three subtitle. Why gyroscope is used, means application. Why gyroscope is used. It is used in compasses and automatic pilots. On ships and aircraft. In the steering mechanism. Of torpedoes and in the internal guidance system in the internal guidance systems installed in space launch vehicle ballistic missiles and orbiting satellites. And orbiting satellites. Then write down the principle of gyroscope. Mechanical gyroscope essentially consists of spinning mass. Mechanical gyroscope essentially consists of spinning mass that rotates around its axis. That rotates around its axis if a gyroscope is installed on gimbals that allow the mass to navigate freely in the three direction of space. In the three direction of space. Its spinning axis will remain oriented. Its spinning axis will remain oriented in the same direction. Even if it change direction. The next question is, how do you find the angle of tilt? How do you find the angle of tilt? One way to measure the tilt angle with reference to the earth ground, with reference to the earth ground plane is to use an accelerometer. Is to use an accelerometer typical example can be found. Typical example can be found in the industry in the industry and in game controllers and in game controllers. In aircraft, the ball in turn coordinators or turn and bank indicators is sometimes referred to as a inclinometer. For a better understanding, we are seeing some videos related to gyroscope.
Join the community of more than 2 million binomists who are investing online with
मैकेनिकल गुरु चैनल को सबसे काम करता है मैं आपको बताऊंगा। जायरोस्कोपिक इफेक्ट क्या होता है इस बारे में हम बात करेंगे। जायरोस्कोपिक कपल क्या होता है।
Hey everyone, it's me, Derek, from the channel Veritasium. And I've been following this series. Gyroscopic precession is just one of those things that throws some of their lecture dem equipment.
So an example would be momentum and force. First thing I need to do,
Gyroscopic precession works.
the first thing I need to do is talk about vectors. Because a lot of things in physics are vectors. That means they have direction. So an example would be momentum and force. Those are two examples of some pretty common vectors. So if I have a cart moving along here, it has some momentum in that direction. And if I apply a force to it, I can change its momentum. So for example, if I push it to the right, then its momentum will increase to the right. It all makes a lot of sense. Well, there's a similar statement we could make about rotating bodies, which is that a torque increases the angular momentum of an object in the direction of that torque. So let's try to figure out those terms. If I apply a force down on this side of the wheel, I create a torque. Now, torque is force times the distance from the rotating axis. You could call it r. So torque is the force applied times the radius away from the turning axis. Now, what's the direction of that torque? Well, we actually use a right-hand rule to define this. And so what you do is you put your fingers in the direction of the radius from the turning axis and curl them in the direction of the force, and your thumb points in the direction of the torque. So the torque is actually out this way at 90 degrees to the force. The force is down that way, but the torque vector is actually pointing out this way. So the angular momentum of this wheel is being increased in that direction. So the more I apply this torque, the more I increase the angular momentum of the wheel in the direction of the torque. So I'm making this wheel have a very large angular momentum out towards the camera, out towards you. Now, before I go any further, let's have a look at this setup that I've got. I have a wheel here hanging from only one side by this rope. And so right now there's actually a torque on the whole system if I let go, because the weight of this wheel is pulling down and that force is applied at this distance away from its pivoting point there. So if I let go, well, it does exactly what you'd expect. The wheel swings down this way. But I want to see that as an example of rotational motion. There's a torque which is pointing out this way, which is trying to increase the angular momentum of the system in that direction. Now, angular momentum in that direction requires that the whole system starts swinging anti-clockwise. And so that is what happens. But what happens if I only let go after I've already spun up the bicycle wheel? Well, in that case, the bicycle wheel would already have angular momentum this way, and so a torque pushing that way actually swings this angular momentum round that way. Okay, so let me try to get the wheel spinning and make it work. Come on. Oh, look at that. It's rotating as we predicted. See, the angular momentum vector is pointing out this way, but torque is pushing it this way. So angular momentum, torque, and torque is pushing that angular momentum vector around. Except not for long, because this appears to be a quite frictionful wheel. So check out Destin's other videos about helicopter physics, and then come check out my channel, Veritasium.
आणि काय समजलं का? काय समजलं का कन्सेप्ट?
Veritasium, where you can find
डोक्यावर गेलेलं दिसतंय.
I think we should explore a few solutions.
Grammarly suggestions catch.
This is a gyroscope. It consists of a metal wheel mounted on an axle. The wheel and axle spin freely, secured in a metal frame. This simple device can behave in the most unexpected ways. The components of this simple mechanism are obvious, and it doesn't seem to have any special capabilities. Try to stand it on end and it falls over. Try to suspend it like this and it drops. Apparently it can't defy gravity. But spin the wheel and all that changes. A string provides a simple method to spin the wheel. The first thing I notice about the spinning gyroscope is that it resists attempts to change its position. A resistive force appears when I attempt to tilt or rotate the gyro. Now when I stand it on the tabletop, it stays vertical. The spinning wheel is creating a force that holds the gyroscope upright. When the wheel stops, the force disappears and the gyroscope falls. Incredibly, this force will support the gyroscope like this. It appears to be levitating. A spinning gyroscope will balance on a string. You can even lift the gyroscope with a string looped around one end. This interesting behavior is difficult to explain. Physicists have determined that a rotating wheel has
video is
angular
related to your
momentum,
application.
similar to the momentum that a
Connected to your
stone flying
application.
through the air has.
Missile, pallets.
To change the direction of the
Compass.
stone requires a force. Similarly, changing the orientation of the rotating wheel requires force. The spinning wheel prefers to stay oriented as it is, and it resists any attempt to change that orientation. The fact that gyroscopes will maintain a particular orientation in space is very useful. In modern aircraft, an inertial guidance system uses spinning gyroscopes to monitor and control the orientation of the aircraft. The gyroscope is suspended in a special cage that allows it to maintain its orientation independent of the aircraft's position. If the aircraft rolls, electric sensors and contacts connected to the gyro send information to the pilot about the aircraft's orientation. The Mars rover explores the surface of Mars using spinning gyroscopes to provide stability and navigational information. This full-sized robotic helicopter flies without an onboard pilot. Gyroscopes provide stability and navigation. Gyroscopes have become essential components of aircraft, ships, robots, and spacecraft. If you're interested in experimenting with a gyroscope, they are available from online science and hobby retailers. The gyroscopes I am using are manufactured by Tedco Manufacturing in Hagerstown, Indiana. They are identical to toy gyroscopes first manufactured over 90 years ago. More science and technology related videos can be found at our website, hylaroad.com.
I think clear about gyroscope. Then next heading is hot wire anemometer. Give the heading hot wire anemometer. Hot wire anemometer. In that, write down constant current method, and second one is a constant temperature method. Write down constant current method and draw this diagram. Constant current method and draw this diagram.